date time, GUID, unique identifier, base type. Okay, and 15 are fixed length. 15 are fixed length, and all these fixed length types are structures. 2 are variable length types, and they are classes. 15 are pixel length types and predefined structures. 2 are variable length types and they are classes, predefined classes. Okay, that's what I said to you. And declarations also we discussed in the last class. But let me show them practically today. Using system, class, types demo. Look, guys, I want to declare a field int x or int a, and I'm declaring a variable here int b. Okay, but declaring a field without initializing is valid, but declaring a variable without initializing is not valid. Last class I said to you, variables must be initialized, but fields have a default value. If I don't initialize, what is the value of A? A value 0. What is the value of B? Error, no garbage. What is the value of B? Error, it's an error. Let's try this. Actually, this is a static or non-static? Non-static. And what I thought you meant, non-static requires instance of a class. And I'm not going to create any instance. For the time being, when we start object-oriented programming, I'll tell you creating instances and all here. Don't bother about it. But for the time being, I'm making it. So no need of instance now. Okay. Well, and observe it, guys. I want to print the value of A. Console dot write line A. And same way I'm writing console dot write line B. Okay. Observe all of you. When I'm trying to access the A will not give me any error at all. All of you carefully read this. Use of unassigned local. Understand the terminology. Variable. Use of unassigned local variable B. You're trying to use this unassigned. What did I say? Initialization is mandatory. Proven? Otherwise, it's an error. Are you clear? See now, I'm giving is equals to 1. Some value. Now it is valid when? Now it is valid. See now, you won't get the error. No error, see. We have a warning. Read the warning. Concentrate, man. What is it? Field, not a variable. Field. That's what I said here. The terminology is important. The terminology is important. Here, what it said here? Variable. But here it is telling you field. Field what? Is. And we'll be having a default value 0. Clearly telling you, see. Okay. Listen. You get error, your code is not compiled. You get error, your code is not compiled. You get a warning, your code is compiled and will execute here. Warning, just it's a warning, not any error. If you get an error, what is the meaning? Code is not compiled and code will not execute now. But you get a warning, code is compiled and will execute also. Okay, watch it, code will execute or not, see. Types, demo. Executing, see. See there, A value 0, B value 1. Oh, just to make you understand, value of A is, and here, value of B is. Recompile and execute, you can check. Even I did not initialize, A is working. But if I don't initialize, B is giving an error. Clearer or not? What did I teach you? Field has a default value. Variable doesn't have a default value. Variables must be initialized at the time of declaration. But fields not required. If you don't initialize, default. If you initialize, well and good here. If you don't initialize, then also well and good. If you don't initialize, default value. If you initialize, what value you given, that value will come. Okay. Well, one more thing I want to show you. I said you this in the last class. You will be declaring, you will be using all the C# types in the code. You will be using all the C# types in the code. But after compilation, everything will be converted into CIL types. Everything will be converted into CIL type. You declared int, but in CL format, what is it? Check it out. I'm showing you. Watch it. Console dot write line. Okay. Value of A is you printed now. Now I'm printing you type of A. Did you understand the meaning of it? Array, what is the type of A? Is which type? A is which type? How to get it? A dot. There is a predefined method called as get the type. Simple Englishman. Get the type of A. Get the type of A. Same way. Here also I'm printing. So observe it. What is it printing? System.int32. It is not printing as int. Notice that. What is printing? System.int32. Why, sir? That only I said you. You will write int, but it will convert into system.int32. Int is given for what? Because all of us came from C language background. And in C language, we don't have int32. What we have? Int. So what is it telling? You will use int only. I will convert into int32. Are you clear? Yes or not? Okay. So that's what. So system.int32. Everything will be converting into the appropriate type to you basically automatically now. That's what happens internally. But I don't require to use anywhere as int32. What I use? Int. Enough. Okay. Fine. Next, one more thing also, watch it. All these things I was teaching you in the last class, I was practically going to show you now. That's it. Watch it. Float f is equals to 3.14. Is an error. Is an error. What should I write? F there. If you don't write, check. Notice that? What is it telling you? Array double cannot be converted into float. Use an F suffix. So compulsory record use a F suffix. And watch it. Console dot write line. Value of F is F. And then I'll say you type of F is F dot get it. Observe. Don't bother about the warnings on the screen here. Ignore them. Check. Single. Float is single. Okay. Now guys, I want to declare a double here. Double D is equals to 3.14. Valid or not? Come on. Yeah, that's valid. No issues with that. You can see. What is the double? System.double only. Double is system.double only now. See there. System.double. Try with a decimal. See there? Error. What is error? Use an M suffix. You're required to use a M suffix to this. You're required to use an M suffix. See there? All the three I shown you. Float, F suffix. Double, nothing required. Decimal, M suffix. M should be used as a suffix. You can see single, double, yes, all three. Is that clear, everyone? So, are you clear? Everything is converting into CIL type. And I showed you the actual names. And also another thing I've proven you. What is it? F and M should be used as suffix for float and decimal. Third thing, you declare a field, initialization is optional, but you declare a variable, initialization is mandatory. Variables must be initialized at the time of declaration. Otherwise, you get an error. Must and should, initialization should be done at the time of declaration only. Is it clear, everyone? Yes or not? This is how the variables and fields will be working. Are you clear about data types now? Okay. So this is all what I explained to you in the last session, guys. First, I explained about data types. Then I said about all these points. Array, by 2 bytes, how it converts, all those things I said you. Then I explained about how to declare your variables and fields. Then I said you what is a field and what is a variable. And these are all the points to explain to you. What is a type, what is name. Okay. Like what are the default values? The default values are only for fields, not for variables. Okay. And I explained about modifiers. I explained about constant. I explained about read only. Read only. All the things. Okay. I will give you a clear picture going forward. When should I use constants and when should I use read only? We'll talk about it. Don't worry. Where constant should be used, where read only should be used. We will get a clear understanding about it going forward. But one thing you all remember, constant means cannot be modified after declaration. Read only means cannot be modified after initialization. Last class only I said, well, you blank faces, everyone is putting blank face like I'm telling you freshly now. Did you read the notes? Louder. Clearer. Constants in read only. Constant means cannot be modified after declaration. Read only means cannot be modified after initialization. One cannot be modified after declaration and the other cannot be modified after initialization. That is the difference between constants and read only. Okay. Is the program I shown you now? Types demo, field, variables, all the things. Is it clear? Well, now I used the method in the code. Remember, what is that? Read it. Type of a variable or field or instance on which it is called. It will tell you what type is it now. What type is it? The type means it will tell you which format. CL format. That only shown you. F dot get type. What is shown you? System dot single. Did not show you float. System dot single. Why? Float is single in CL. Float is single in CL. Okay now? Not D, it is M. We should use M. Okay. Yeah, next. Guys, listen. Let me explain you in detail about these data types. Last class, I given you the list of the data types. Now, today, I want to clarify you this one. What do you know? Data types are divided into two categories. Data types are divided into two categories. First one. Second one. Reference types. So remember all of you, data types are divided into two categorizations. First one is called value types and the second one is called as reference types. So now the question is, sir, what is a value type and what is a reference type? Come on, answer this question, all of you. I'm declaring int I is equals to 100. Some memory is allocated for this int now. How much? 4 bytes. Perfect. Where is it allocated? Where is the memory allocated here? Stack. The memory is allocated on a stack. What is the stack? See, every program, you're executing a program, Matt. You're executing a program. When you execute a program, every program requires some memory. I repeat, you're executing a program, and every program requires some memory. It needs some memory basically. Okay. Well, now basically what happens, whenever whenever you are just trying to run a program, whenever you try to run a program, when the execution of the program starts, operating system will create a data structure called as stack for storing the values. The memory is stack only now. The memory is what we call as stack. So basically, whenever the execution of the program starts, what will the operating system do? Operating system will be creating a stack for you. Are you clearer or not? What is that? Whenever a program execution starts, operating system will create a stack. What is a stack? A stack is a data structure for storing the values. I repeat, a stack is a data structure for storing the values. It's a data structure actually for storing its values. What is a data structure? A data structure means some memory. Data structure indicates some memory. So how this stack looks like, if you already came across the concept of the data structures in your college days or in your C language, you might have a basic idea of it. This is how a stack will be present. This is how a stack will be present. Whenever you start the execution of the program, operating system will create this stack now and gives to the program for storing all its values. And this works on a principle called last in, first out. We learned in mathematics in a school days, remember? Last in, first out, or first in, last out. What is that, sir? Actually, when I declare the variable int I is equals to 100, 4 bytes of memory is allocated now. Where this memory is allocated? The memory is allocated for you on the top of the stack. Where is it allocated? Top of the stack. Right now, this is the top of the stack. Array, see where my cursor is, that is the top of the stack now. Means right now, the memory allocation is done here. Are you clear? Right now, the memory allocation is done here. It is the top of the stack actually. Did you understand me or not? This is the top of the stack. I is equals to 100. Here the memory is allocated now. Okay. Now I'm declaring another thing here. Char ch is equals to a. 2 bytes of memory allocated on the top of the stack. Means where is it allocated? Top of the stack, man. Everything will come on the top now. Understood? So now your ch comes and sits here. That is the top of the stack. Suppose you declare one more field that comes again and sits on the top of the stack. I'm declaring double D is equals to 34.56. Same again comes on the top now. How much memory? 8 bytes. The 8 bytes of memory will be allocated for you on the top of your stack. D equals to 34.56. Did you understand this one? So every value comes into the stack and sits on the top of the stack. Okay. So how many you declare? Everything should come and should be sitting on the top now. One by one will come now and sit on the top. Clearer or not? Okay. So that's what. So now talking more about this stack, listen. Stack works on a principle last in, first out. Stack works on a principle last in, first out. Tell me who came last into the stack? Double. Tomorrow, if you want to clear the stack, you need to clear the double first. Afterwards, character. Afterwards, integer. I want to clear the integer first. Not possible. Not possible. Why? I said you that only. Last in, or otherwise you can read it as first in, last out also now. Who is first in? I. So last out is I only. Because one direction only now. So everyone is entering on the same, should exit on the same direction only now. See, we are sitting in a classroom. Our classroom is a stack here. Everyone comes in the same direction, goes out in the same direction now. Are you clear or not? So basically, that's how exactly the stack is going to behave, or the stack is going to be working for us. So it is going to be first in, last out, or last in, first out. Whatever you say, both are same. Okay. Next, another important thing, whenever a program execution starts, operating system will create this tag and gives to the program telling you store your values in it. Let's see, you go to a grocery store, a big grocery store now. When you go to a big grocery store, in the entrance, you are given a cart. Correct now? You carry the cart inside and start picking the items in the cart and put them in the cart now. And how do you feel? That is a stack only. And all your items, the first item you pick will be in the last now. The last item you will be picking in the first. Correct? Okay. Now tell me, can someone put items in your cart? You are shopping now in a cart. I came there. I put my items in your cart and telling you, I collected the billing counter, come there. What do? You take it and throw it out. Why will I carry your items now? Am I right? Exactly. Here also the same. Every program will have its own stack. When execution starts, one stack is created. Another program starts, another stack is created. 10 program starts, 10 stacks will be. Every customer is given a cart. Every customer is given a cart. And every program is given a stack. Got it? No two programs can share the same stack. No two customers will share the same cart. Right up. No two programs can share the same stack. Stack is specific to the program. When is it created? When the execution starts. When is it destroyed? In the end of the program's execution. In the end of the program's execution, it is destroyed. When will you leave the cart? When will you leave the cart, man? When will you leave the cart? When I'm exiting from the store. When I'm exiting from the store now, my billing is completed now. I'm going out of the store. What do? I leave the cart and I will take my goods and go away out of the store. I take my products and go out of the store now. I'm leaving the cart at the exit. I'm taking the cart in the entrance. I'm leaving the cart at the exit. See, program execution started, stack is created. Program execution completed, stack is destroyed. Okay, no two programs can share the same stack. Every program will have a separate stack of its own. Okay, and very importantly, the stack will be under the execution of the execution. When did you create an object here? You did not create any object now. Why are you talking about objects and all? That's a variable. Variables and fields. They are scalar types. No need object. When we talk about objects, I tell you. Object means instances. Then I talk about it. We are talking about only variables. That's it. Variables and fields. Well, so like this, it starts allocating the memory for each and every of the things. So what are the points we learned here? Point number one, every program, when the execution starts, a stack is created and given to it for storing its value, and the stack is destroyed in the end of the program's execution. Point number two, stack will be under operating system. Stack is specific to a program, and no two programs can share the same stack. Third, stack works on a principle last in, first out, or first in, last out. If you come into the stack first, you will exit from the stack last. If you come into the stack last, you will exit from the stack first. Okay. And fourth point is, stack will be under operating system's control. Stack will be under operating system. The operating system is responsible for creating the stacks and destroying the stacks. Who is responsible? Operating system is responsible for creating the stacks and destroying the stacks. For everything, operating system will create the stack, destroy the stack. All these things will be done by the operating system. Okay. Lastly, one more thing about this stack. Stack can allocate the memory only in fixed length. I repeat, stack can allocate the memory only in fixed length. What is that? At the time of creating, at the time of allocating the memory, you can ask for a size. I want 4 bytes, allocates 4 bytes. I want 8 bytes, allocates 8 bytes. I want 16 bytes, allocates 16 bytes. But once after allocation is completed, you say, no, increase it to 18 bytes or 20 bytes won't be possible again. You go to a cloth store. You are purchasing some cloth for a dress material or for a shirt or something. You're purchasing some cloth. And the cloth is present in bales, big bales. You ask 2 meters of the cloth now. And the person cut the 2 meters. After cutting the 2 meters, you said that, no, 2 meters won't be sufficient, make it 2.5 meters. Will you increase your, what do you say? First pay bill for the 2 meters. Again, I'll give you another 2.5 meters, pay bill for that. Yes, sir, not. You cannot increase or you cannot decrease. The 2 meters is cut now. Afterwards, you say, half meter is unnecessary for me, take it and give me 1.5 meter. I take it anyway. You pay for 2 meters only. Right or not? Once the cloth is cut, cannot be increased, cannot be decreased. Here also same. Once allocated, the memory cannot be increased or cannot be decreased. That's what we call stack can allocate the memory only in fixed length. That is, once allocated, it is final. No increasing, no decreasing will be possible. Did you understand, all of you? Okay, fine. Now, answer this question. I'm going to declare a string str is equals to hello. I'm declaring a string now. String s is equals to hello. How many characters? 5. How many bytes? 5 only. So what I said to you, English is 5 only, na? Either Hindi, then 10. English, na? It is 5 bytes. Okay, so 5 characters, 5 bytes of memory. Suppose the 5 are Hindi characters, 10 bytes of memory. The 5 bytes of memory has to be allocated now. Where? In the top. Where it is allocated? In the top. Where it should be allocated here, right? Yes or not? So how much memory has to be allocated? 5 bytes. And storing you the value. S is equals to hello. Are you guys clear? So S is equals to hello, because the fourth one is coming and sitting on the top of the stack now. Coming and sitting on the top of the stack. Allocated the memory for 5 bytes on the top. Now, answer my question. Tomorrow, you declared int I is equals to 100. Going forward, is it possible to do this? A declaration is completed here. Now, can I say I plus equals to 1000? What is the value of I now? 1100. 1100. Correct? Can I store this 1100 under the 4 bytes memory, or do I need to increase the size? I'm not getting any response. Did you learn this in C language basically? Open the mouth. Can I store the 1100 under the same 4 bytes memory, or do I need an increase in the size? Can we store it or not? Yeah, why? Already we learned in the last class, 4 bytes means 2 power 31 minus 1. 2 power, there's a maximum capacity you can store the 4 bytes now. 1100 is within that range only now. So can I store this in the same 4 bytes memory or not? Clear now? Okay, now I value changes to 1100. Okay, next, I'm writing S plus equals to world. What value? Hello world. How many characters? Can I store this hello world under the existing 5 bytes? Possible, huh? Means you require the size to be increased or not? How much it has to become? 10. Now it is 5, should become 10. Correct now? But what did I say you 5 minutes back? Stack can allocate the memory only in fixed length. Na? Once allocated, cannot be increased or decreased again now. Understood me or not? Now tell me, will it be possible to modify the string value? Will it be possible to modify the string value? No, it won't be. It won't be possible to modify the string value. Why, sir? And how will you modify the string value, guys? Because if you want to modify, you require 10 bytes of memory now. So how much is allocated? 5 bytes. Can the size be increased? No chance to increase the size or no chance to decrease the size now. So will it be possible to change the string value? No, you cannot. You cannot change the string value. Did you understand the problem? That is why strings are not stored on the stack at all first. Strings are not stored on the stack. When it is stored there, actually, it is stored for you in a different area or a different location called as memory. There is another place where your data will be stored. What is it? Memory. It is not stored here, guys. Where is it stored? There is one more memory location called as heap. Will be stored into the heap memory basically. And when you talk about the heap memory doesn't have any restrictions like last in, first out, or first in, last out. Stack is like a classroom. Stack is like a classroom. You enter into the classroom, you need to sit here until the class is finished. Until the class is finished. It's just like a classroom. Okay? But a heap is like a cinema theater. What is that? You enter the theater now, you did not like the movie. You can come out of the movie now. You can come out of the movie. You got a phone call. You go out, talk to the phone, and come back again. But the same thing you cannot do in a classroom now. Are you clear? See, what I'm telling is a warning you. Don't try to go out of the class when I was teaching. Initially, some people done it. I did left it. If you try to go out of the class when I'm doing, next time you will not be allowed in the classroom again. Be careful. Okay? And using the phones in the classroom. Using the phones in the classroom. If I notice anyone using or touching the phone in the classroom, I'll immediately ask you to get out of the classroom. Are you clear? Put your phones inside. Don't try to keep in your hands also. Put your phones inside your bag or pocket or put in the flight mode or silent mode. Don't try to use them in the classroom. Is that clear, all of you? And one more thing. From tomorrow onwards, be in the class by 11:15. Are you clear? By 11:15, be in the class. By 12:45, I will leave the class. Is that clear? Don't be late in the classroom. Yeah. So, stack is like a classroom. You enter, you should sit there until the class is completed now. You will not go out. But heap is not like that. What is heap? Heap is like a movie theater, man. You can come at what time into this now? You got a phone call, you can go out and come in. You did not like the movie, you can go out of the movie theater now. Everything is possible. But stack doesn't give you the permissions now. Understood or not? It provides you a beautiful concept called as dynamic memory management. What is that? Dynamic memory management means it is possible to increase the size, decrease the size, delocation, all possible, but nothing possible in stack. If you come to the stack, when it's the stack destroyed, end of the program only. But I said you can leave the class only in the end. Here also, when it's stack destroyed, end of the program only. Stack is created in the start, destroyed in the end. But that's not the case with heap now. You enter the heap here, your job is done. You can leave. You can exit now. You don't require to wait until end of the program's execution. That's why when I declare a string here, the memory allocation for the string will be performed on the heap actually. Something like it will allocate the memory in the heap now. Okay. After allocating the memory in the heap now, the address of this now, starting address of this will now come and sit in the stack. What will this contain? S is equals to address, not the value. All of you concentrate. S is equals to address. And this is the address pointing to the heap memory. This is how it works. Did you guys understand me? Tomorrow I want to change the value of hello world. Can I change it? Yes, you can. Why, sir? Because stack is giving the provision for increasing, decreasing, deallocating. Everything is possible. But stack doesn't give you that permission. Gives the permission, gives the permission, but stack doesn't give you the permission. Is it clearer or not? Understood my point? Okay. So fine. Now you'll have a doubt here. Sir, what you listed 17 data types here and telling you are dividing them into value types and reference types. How do I identify what is value type and what is reference type? What is a value type and what is a reference type? Okay, I'll give a clarity. Just listen. First understand. How do you say this is value type and this is a reference type? Okay, listen. If the value of a type is stored on a stack, it is called value type. If the address of a type is stored on the stack, it is called reference type. Did you understand the definition? What is that? If the value of a type is stored on the stack, it is called as, watch it, integer, character, double. What are they storing? Values. They're storing values. If the address of a type is stored on the stack, it is a reference type, man. Look at the string. What is it storing? Address. It's not a value type, it's a reference type. Okay, now? So how do I recognize, what comes under value types and what comes under reference type? Very simple, man. All fixed length types are value types. All variable length types are reference types. How many types totally? How many types totally? Asked here. 17. How many? In this 15 are fixed length. Now that is only your answer now. 15 are fixed length. All fixed length types are value types. Are variable length types. All variable length are reference. How many variable length types are there? So what are the two? String, object. So string and object are reference types. Remaining 15 are value types. Are you clear, everyone? Yes or not? Okay. Now finally, listen. It will be under whose control? Stack is under operating systems control. I already said you. Stack is under. Now heap is under whose control, sir? Actually, guys, this heap is under developers control. Heap is under developers control. If you work with the concept of the data structures in your C language or anywhere, we use the function called malloc. When you say malloc, it will allocate the memory for you. Where it allocates? Heap only, not on stack. Not on stack. Where the memory allocation is done? Heap. Actually, heap is under developers control yet. Whose control? Where in our C language, C++ language and developer control. But when you come to .NET and Java and Python, it is under the control of garbage collector. It is under the control of garbage collector. Developer doesn't require to call mallocs or callocs to allocate the memory here. Everything is implicitly performed for you by the garbage collector. That is why in modern programming languages, it is renamed as managed heap. In C and C++, we call it as heap. Java, .NET and Python will call it as managed heap now, not as heap anymore. It is managed heap because it is managed by garbage collector, not by developers. Olden days, developer, now garbage collector. Did you catch my point? Yes or not? Now tell me which one looks futuristic, stack or heap? Which one looks more futuristic? Stack or heap? Heap memory, na? Yes or not? Then we'll have a doubt there. Heap is more futuristic. No, sir. Why do I need a stack? Why do we need the stack? I tell you. Which one is faster? What are you thinking? Which one is faster? Stack or heap? Stack is faster, not heap. Why, sir? If I want to access the string value, listen, watch the picture carefully. If I want to access the string value, can I access it directly? No. First, I should come to stack, pick the address, go to heap and get the value. Means, you understood one thing? The primary memory of your program is stack only, not heap. Heap is secondary memory. So stack is mandatory memory now. Heap is a secondary memory. Heap might look futuristic, but your program will not run without a stack. The primary memory is always stack only, not the heap. And what is faster means stack only is faster, not the heap. The only advantage with heap is dynamic memory management, except that Fastness also stack only. Primary memory is also stack only. So every program has their own stack now, but all programs will share the same hoop. Did you understand me or not? Every one of you have your own notebook, correct? But all of you are sharing the same screen. Got it? Everyone has a separate stack, but all will have the same heap. Heap is common for all. That stack is separate. 10 programs running now, 10 stacks will be present. But how many heaps will be there? One only. All will share the same heap. So don't forget, the primary memory of the program is not heap memory. The primary memory of the program is stack memory. Stack must be there. Then only you can use the heap memory. Without a stack, you cannot work with the heap. So stack is important for us. Are you guys clear about value types and reference types? Look at this. Look, guys. Starting from here. Come on. First point. Categories. Reference types. First, value types. All excellent types comes category of value type. Example. All these are value types only, man. Okay, next. Understood? Value type will store its value on the stack, but reference type will store its address on the stack. If value is stored there, value type. If address is stored there, reference type. Third point. Did you understand when a stack is destroyed? End of the program. End of the program. Next. I very clearly said you. See, imagine stack is like your shopping cart. Your cart is your own. When is the cart created? Perfectly that suits you. The cart is given to you when the shopping starts. The cart is taken from you when the shopping ends. Stack works on last in, first in, first out only. Am I right or not? The first product you pick will be in the bottom now. When you go to the billing counter, what will you take it out first? The last item, what I put on the cart. Then the perfect example for last in, first out or first in, last out. Okay, now? Next. Once allocated, it's final. You cannot increase the size. You cannot decrease the size. Both these two activities will not be possible. Okay, next, reference types. Understand carefully, they will store their values on heap memory and their address on reference is stored on stack memory. Example, string and object. Second point. All will share the same heap. No separate heaps for each now. Third point. Called as managed heap. It's not heap memory anymore. From now, we should call it as managed heap. Okay. We can store numbers in stack, but not letters. Letter is also stored on stack. Why you're calling number or letter? Strings. Say like that. Sachin, what's the picture, man? The value is stored on the heap. The address is stored on the stack. Tomorrow, the primary memory for a program is stack, not heap. So you declare the string now. You want to access it. So if you want to access the string now, what you require to do? First, you require to come to the stack. Pick the address. After picking the address, what you should do? You go to heap now, and there the value is present. Get the value now. Are you getting me or not? Okay, you will be getting the value from that particular location. So where is it present? It is present on the heap. Present on the heap. See something like this here. You have a locker in your home. You have a locker in your home. You store all your money, jewelry, everything in the locker. This is one option. But another option is you are taking a locker in a bank. You are taking a locker in a bank. You don't have a locker in your home, man. So for security reasons, the nearest bank to your home, you are taking a locker now. You know lockers in a bank? You can rent the lockers in the bank. They'll be under the bank's production now. They'll be under the bank's production. What you can do? You can take your items and put it in the bank locker. And anytime you went to a bank locker for taking a locker in the bank, there'll be a locker room here. In a locker room, 100 to 200 lockers will be there. So many lockers will be there. And every locker is given for one to rent now. Are you getting me or not? Every locker is given for one person for rent. See now, everyone is storing their values under the bank's locker. All are sharing the same bank's locker now. Second option, you can purchase your own locker and put it in your home now. Your own locker is like stack now. What do you mean? It's a bank locker. It is a bank locker. Tomorrow, you take a locker in the bank. They'll give you a number. Right? They'll give you a locker number. I'll give you a key. You want to operate the locker now. What do you require to do? You're required to go to the bank and tell your locker number. You're required to tell the locker number. And for this locker, 2 keys will be there. One key will be with you and one key with you will be with the bank. Okay, when you say I want to use my locker, what they do is the bank person comes into the locker room, puts his key, opens the locker and goes away. Now you need to put your second key and open the locker now. Until then the locker is not open. Are you clear? And this key is a reference for your locker on the bank's. Correct or not? See, this is the value here you stored now. Then what is the reference to that for me now? The address. The address is coming and sitting on the stack here now. Tomorrow, this is my own. This is my own. So what I'll say, I'll put the address and go to heap memory. And there my value is present. Are you clearer or not? There is your value. If that address is not with you, how do you know what is your value there? So many lockers are there. Go there, open locker number 10. Whose locker will you open, man? You should open your locker only. Yes or not? You cannot go to your locker room and say, open someone's locker, I take the money from that man. You need to open your own locker. So that's why I give a reference to you. You need to pick it up and consume it. Is that clear, all of you? That is what. So the actual address will be here. This is your own now. From here you go to heap. The value will be present for you. Okay? Yeah. So coming back and see. Suppose we declare fields in a program like this now. And see the memory is allocated for them as following. The same picture I shown you, I drawn and shown you. The address referring to the heap memory. Are you guys clear about value types and reference types? Yes or not? So value types will store on stack. Reference types will store their values on heap and address on stack. But value types will directly store on the stack only. But reference type will store their values on the heap and address on the stack. There are 2 predefined reference types. What are the 2? String and object. Rest of the 15 are value types. And a simple point to remember for all of us. I already said you in the last week. What is it? 15 are fixed length. Correct? Fixed length are value types. I'm extending that point. 15 types are fixed length. Fixed length types are value types. 2 types are variable length. Variable length are reference types. That's it. Fixed length is value type. Variable length type is reference types. Okay. Well, next. Just a minute. By using address on stack, how do you get to know what value is stored on heap? This question is funny, man. This question is really funny. You know the address of someone. You know the address of someone. You go there and knock the door. You will come to know who is present in that address now. Yes or not? You know the address of someone. You go knock the door. You will come to know what is present there now. Correct now? And see this question. That only I said you know the address now. Go and see what is there now. I'm telling you the address. Go there and check it out. You'll come to know the value. You'll come to know the value. Okay. Just like you go knock the door, open the door. Yeah, you come to know there is a person present here now. The same thing only. The value is present in the heap now. On this address, go to the heap. Go and check it out. What is the value present? See, I want to print S value. I want to print S. What is present in S? I don't know. Let me go to heap. And on the heap, I come to know what is present there. What is present? LOL. I pick that LOL, print on the monitor. That's how we come to know. Got it? Yeah. Few more things about these data types, man. Few more things about these data types. Already clarified you about value types and reference types. Some few things just understand. See, the foundation should be perfectly strong here. If you are having a strong foundation only, you can build application. Tomorrow, every application, you'll work with the data types only. Without data types, you cannot write the code now. You need to get a clear understanding about all the things. That's why I'm spending a lot of time with your data types. Even last session also, I explained about data types only. Are you clear? Okay. Today also, we're talking on data types only because that is important. We need to have a strong foundation on the data types. See, watch this. I'm writing main method like this in a class. I'm writing a main method in a class like this. Inside of it, I'm declaring string s, valida, invalida. Morning only I said you. Invalid na. Variable na. Variables must be initialized. It is an invalid statement now. That is invalid. But unfortunately, I don't know the value that has to be assigned to it. I don't know the value that has to be assigned for it. But what we're telling, assignment is mandatory now. But if we don't assign, it's an error. It is an error. So what you can do, you can say is equals to null. What it indicates? Unknown. I don't know the value. I don't know the value. And it's a valid statement here. Same like this, object O is equals to null. Valid. You can do. Same like this, I'm declaring a int. Invalid again. Invalid again. But I don't know the value. I don't know the value. What should I do? Array, 0 means unknown value. If 0, why not 1? Tell me. 0 means unknown. 0 means unknown. If 0, why not 1? 0 is also value. I want to say I don't know. So what I want to do? Null. But it is invalid, man. It is invalid. Same way I'm declaring a double. B is equals to null. Is invalid. Why, sir? It is valid for object and string. Why is it not valid for int and double? Because null is a value that can be assigned only to, but not to. Right, this is why I first explained to you what is the reference type and what is the value type wise. Read that carefully. We have this problem in the industry since 50 years. 50 years. C language also not possible. C++ not possible. Java doesn't support. Python doesn't support. C# doesn't support. None of the languages supports. But databases support. But databases support. What is that, sir? In all databases, value types will accept null value. Take Oracle, take SQL, sir, whatever you take, null values can be stored in the value types. Who doesn't support? Programming languages doesn't support. I repeat, guys, who doesn't support? Programming languages doesn't support. Who supports? Databases supports. When will the problem come to you now? Tomorrow you started communication with the database. Tomorrow you started communication with the database. Then problems will come. Why? There is an integer column in the database sending a null value. But my application is telling I won't accept a null value now. Got it? I started my communication with the database here. I'm pulling some data from the database into my application now. So there is an integer column in the table now that sent me a null value. But my table, my application is telling I won't accept a null value. What it accepts is only a value. No nulls are accepted. Is a problem. So that's why we face this problem for many years in the industry. What the problem? Because of this problem, every time before you assign a value, we used to perform a null check. Is it a null or not? If it is null, we used to assign 0. If it is not null, then we used to assign the exact value. Means you record to write a condition for everything now. Suppose the 10 value types are there, and if else condition should be written now. That becomes complicated. Not that complicated, man. Heavy coding. When code increases, size increases. When size increases, performance decreases. This is the challenge for the developer to check all the conditions. To overcome this problem, what happened, in C# 2.0, they introduced a concept called nullable value types. That is, from now, null can be assigned to value types also. But while we are declaring, we need to suffix question mark to the type name. What is that? Look, guys, what did you write on the top? Int I is equals to null. Invalid null. This is how you should write. Clearer or not? How to write? Open the mouths, all of you. Louder. Int question mark I is equals to null. Int question mark I is equals to null. Same way. Double question mark D is equals to null. Is valid, guys. All valid. Okay, but see, int I equal to null, double D is equals to null, invalid. But this is valid. From which version? C# 2.0. Okay. Remember, we have this problem still in C language. We have this problem still in C language. We have this problem still in C++ language. They don't support null values and value types. Okay. First introduced by C#. Later on, this feature was added by Java also. This feature was added by Java and Python also. But C++ still not possible. Value types cannot be assigned with null. Null is assigned only to reference types, not to value types. So now you understood value types are again two categorizations. What are the two? Non-nullable value types, nullable value types. What are these two? What are these two? Non-nullable value types. What are these two? Nullable value types. How to differentiate? Question mark. If I use a question mark, it is nullable. If I don't use a question mark, it is non-nullable. Is that clear, all of you? Okay. So what about strings? Strings are nullable. Array string is nullable, object is nullable. Reference types are nullable only. Problem is for value types only. Because there is a problem for value types only, they added the feature for value types. Are you clear? So what we talked here? We are talking about a feature here called as C# 2.0. Okay now? Now answer this question, all of you. Answer this question. I is which type? The question is foolish first now. You write int I and again asking I is which type? Only yes or not. You clearly written int I and again you're asking I is which type? I is integer, very clearly known to all. Yes or not? Okay. But guys, from C# 3.0, from C# 3.0, you can declare variables like this now. Are you clear? You can declare variables like this by using var keyword. I is which type? Now we need a clarity. I is which type? Because we are not writing int I, we are var I. Are you clear? The question is I is which type? I is of type integer. How did you say that, sir? Now, type identification is performed based on the value assigned to it. Type identification is performed based on the value assigned to it. What is the value? What is the value? 100. So what is assigned is a integer. So it is an integer now. Okay, watch it. Varf is equals to 3.14. Come on. Which one? Double type. It's a double type now. Why? Lesson value. Suppose if you say M here, decimal type. If you say F here, float type. Are you getting me? Where B is equals to false. B is of type string here. Concentrate on your value. When I say P, they become string. Why? It's in the double quotation. Focus on the value correctly. Understood? Okay. If I remove the double quotes, now it is Boolean. S is of type string. Is it clear, all of you? Yes or not? Actually, the new feature introduced in C# 3.0, guys, called as introduced in C# 3.0. We can declare variables by using var keyword. Okay, guys, we have three restrictions here. What are those restrictions? First restriction is invalid. Did you understand? What? Declaration without initialization is not possible. Declaration without initialization is not possible. Why? Based on the initialization only, I'm recognizing the type now. If that initialization is missing, how can I recognize it now? With this value only now, recognize here. If that value is missing, recognition won't be possible now. So this is invalid. First rule. Second rule. Var x is equals to 100. Which type? Now x is equals to 34.56. Which type? Here, int. Right now, here, invalid. Yeah, x is integer now. Will you assign double value? Did not understand? X is integer here. First line, x is integer. Then how can I assign double value? I want to change it. That only said you are not possible. These are the restrictions what we have. Once identified, cannot be modified. Understood? We can use this. We can use this only for declaring variables, but not You cannot use it on fields, guys. You can use it only on variables. So what is the first restriction? Declaration without initialization is not possible. Okay, second restriction, changing the type after initialization is not possible. So we're trying to change the type after initialization. Initialization is done here now, so cannot be changed with the type. What is the third restriction? We can use this only for declaring variables, but not fields. A field declaration is not possible. What is possible? Only variable declaration will be possible. Field declaration will not be possible. These are the three restrictions what we have with var. Are you clear? In which version it is introduced? 3.2. Clear or not? Basically, resolving all these three problems, resolving all these three problems, again, in C# 4.0, they introduced a new data type called as dynamic. Which version? Introduced in C# 4.2. What is this, sir? Look, guys. Now also same. Dynamic D is equals to 100. D is integer. Dynamic D is equals to D is integer. So same as var only now. What is the difference? The difference is all these three are possible now. Did you understand or not? All these three are possible. What is possible? Valid. Valid, guys. Now see, D is equals to 100. D is of type integer. Okay, now D is equals to 34.56. D is of type double. D is equals to false. D is of type Boolean. D is equals to L. D is of type. See, these things are not possible here, but possible here. See, first one, where invalid, valid. Next, here, initialization completed. Again, trying to change, not possible. See now, initialization done. But see, remember the name, guys. What is the name? Really dynamic only. It's really dynamic. So it is going to be dynamic. And also, we can use this for declaring variables and both. You can use it for declaring variables also. You can use it for declaring fields also. Variable declaration is possible. Field declaration is also possible. Observe it. We'll show you practically. Come on, concentrate on this. I'm writing a class, naming it as var dynamic. Any name you like. Okay. Using system class var dynamic. First, let me show you var. First, let me explain you var. Okay. Var I is equals to 100. Console dot right line. You know the value of I now. I am not focusing the printing the value of I. Let me print the type of I. Type of I is I dot get type. Guys, notice it's going to throw you an error. It is going to throw you an error. Why? Declaration initialization is separated. That's not valid for variable now. Compulsory declaration time you should initialize. Check. Read the error messages thoroughly. You will understand the problem. Are you clear? So just then you get an error. Don't come back telling, sir, I got an error. Read the error message thoroughly. Focus on which line the error is coming. Error is coming on line number 6. Try to analyze it first. Try to fix it. If you cannot do, come back to me. I tell you how to resolve the problem. But first, you do your hard work first, how to resolve this. So, did you understand the problem or not? What is that? Line number 6. 1, 2, 3, 4, 5, 6. You did not initialize it. That is why you are getting an error. How about this? Valid or not? Yes, this is valid. Check. No error. No error. Where dynamic into that. Okay, now? And what I said you, I is equals to 34.56. Possible? Possible? Not possible. Check. Recompile. Cannot be converted from double to integer, man. Cannot be converted double to integer, giving an error. So this is also not possible. Now I am declaring where d is equals to. And I will say, what about this? Is it valid? Yeah, this is valid. Always I'll make it as F. Valid? Array, the D of that are your own choice, man. Variable names can be given any name. I, F, or D, no problem. Focus only on the value. You give them your name as a variable name, no problem. Any name can be used. Okay. See again. No error. Single. It's a float. Float means single. And third thing, what is not possible? May only appear within a local variable declaration. They can be used only in a local variable declaration. You cannot use it on the fields. Is it clear, everyone? But watch it here. All these things will be possible with dynamic. All these things will be possible with a dynamic. Okay, I'll show you. Meanwhile, just observe this one. I'm declaring where ch is equals to a. Okay, now where b is equals to true. Next, where yes is equals to hello. Check it up. Where I missed it? Oh, thank you. In that you do single char boolean string. Okay. Now observe. I'll show the same with the dynamic also. Guys, I'm using console dot write line, but not passing any value. We can use it for printing line breaks, extra line breaks. No value, we print you a line break there. Okay, now I'm just adding a line break there. Okay. Now see, dynamic D is valid. D is equals to D is equals to 100. Valid, guys. That's a valid statement. You can observe all of you. Check to separate the outputs, add a line break here. India. See now, declaration initialization separated, but still it worked. Yes or not? And what I say, D is equals to, is that valid? No error, see? Double. Again, D is equals to Z. D is equals to true. D is equals to India. One variable only we used for all five now. The things. All are D only. But here we used five separately. But here you used only one. Understood? Okay. And one more thing possibly. What is it? Dynamic is equals to 100. Is it valid? Yes, it is. Yes, it is valid. But the same thing for where you got an error. Check it out if you want. Possible or not. No error, see? Array, for where I showed you, you can check again. Where? Already shown you now. It can be applied only for a variable declaration, but cannot be used for field declaration. So, three things not possible with where are possible with dynamic. All these three possible with the dynamic now. Did you understand the difference between where and dynamic? See, once again, I'm telling you. When I'm telling you about this, I cannot immediately tell you where do we use it. I cannot immediately tell you where do we use it. In your school, when you're learning in the school days, your teacher has said you at ABCD. On the day when you learned ABCD, you don't immediately know where to use it. Going forward, you came to know these ABCD are used for forming words using which we speak with each other. That's what you learned. Yes or not? Sir, what is the use of dynamic? I cannot tell you now. You don't know anything basics now. So what I'm telling you is, when I was telling these classes, try to understand this and use it. Don't get into your where do we need to use them. Are you clearer? All these things where we use where we use dynamic, everything we will learn going forward. Is my point clear? So now don't put in the mind where should we use them. Only try to understand what is where, what is dynamic. Are you clear? What is value type? What is reference types? How do they store? That's it. Don't get into more of these internal things, where to use, why to use, and all. All this you are going to learn going forward. You are still in the starting stages, man. When we develop the applications, we use all these particular functionalities and features. I shown you all. Amar, okay, you messaged me 12:37. Why are you talking about overloading, man? Why are you confusing yourself? No overloading, nothing. That one I shown, huh? Declaring we can use this only on variables. Yeah, I shown you. I got the error and raised the error and shown you. Okay. But don't talk about overloading, polymorphism. Don't confuse yourself here. We're just learning basics, that's all. Okay. I did not start object-oriented programming or anything. Just understand the basics correctly first. Then we'll talk about all the remaining things later. Are you guys clear till now? Yes or not? All this is about the data types only. Last class, what I said you, today, what I said you. Finally, let me end up with one last thing. Let me end up this with one last thing now. What is it? Boxing and unboxing. Okay. What is this boxing and unboxing? Listen. Int I is equals to 100. Okay. What is I? Value type. Value type now. Value type now. Clear? Object is here. Reference type. Reference type. Correct now? Answer my question. Can I say is equals to I? Yes or no? No, no? Okay. Read this point once. Forget it. Up to here enough. Object is a parent of all the types, so capable of storing. But you're telling you cannot store integer now. I said you already you can store anything in it. And you're telling no. Means you're not reading the notes here. Valid man. Object is a parent which can store anything in it. You can store integers, you can store double, you can store date time, you can store GUID, anything can be stored now. It's a case, it's a parent, anything can be stored. Okay. So is it valid means? Yes, it is valid. Okay, it is valid. So object obj is equals to I is a valid statement. Are you guys clearer or not? And actually, we call this process as boxing. What is boxing? Converting Did you guys understand what is boxing? All are interconnected. See, first I said you boxing and unmover, value types and reference time. Now relating to that, I'm telling you now. What is it? This is a very important question in interviews, guys. What is boxing? Boxing is a process of converting a value type into reference types. What is unboxing? Converting a reference type into value type is unboxing. And when I explain you about boxing, you will immediately grasp the meaning of unboxing. Correct? No? What is unboxing? Converting a reference type into value type is unboxing. Okay. Now, after you give this answer, this will be the next question. What is the next question? String str is equals to hello world. Are you clear? Convert this to an integer. I'll give you an appointment letter immediately. You only said, not converting a reference type to value type is unboxing. Convert it. No expression on the face. Not understanding. What did you say? Converting reference type to value type is unboxing. You said or not? Come on, convert into integer now. Reference types cannot be converted to value types at all. Yeah, that is why we moved from stack to heap. Nah, morning only said you. Reference types cannot be converted to value types. If you convert to value types, they should come and sit on stack now. But you cannot store it on stack now. So the answer what you're given for unboxing is wrong. That's what I'm telling you. 99% of the people say same answer. When you say this answer, this is the next person. Give a string like this. Convert into integer now. You said no, convert into integer. I give an appointment over next minute now. Reference types can never be converted into value types. Not possible. Then what is unboxing, sir? Listen, what is unboxing? Careful. A value type which is converted into reference type, okay, which is converted into reference type, is converted back to value type, we call it as unboxing. Did you understand that statement? Read carefully. Understood? Okay. I'll tell you in simple words. Watch. I have a value type. Can I convert this into reference type? Come on. Can I convert this into reference type? What do you call this? Boxing. I have a reference type. Can I convert this into value type? No. Guys, it's not possible. This is invalid. Okay. Now, what is unboxing? Follow me carefully. I have a value type here. This value type is converted into reference type. I want to convert this back into, this is called unboxing. Are you clear or not? Reference types cannot be converted to value type. What is it? It's a value type, but it was in which format? Reference type format. Again, I'm converting back into value type. That is called unboxing. Now tell me, can I convert this back into integer? Yes or not? Yes, I can convert. Why? Because that is integer only present in object format. This object can be converted back into integer. Okay, but a small pointer. But unboxing requires explicit conversion. Unboxing requires explicit conversion. What is that unboxing requires explicit conversion? Understand these terms too clearly. Implicit, explicit. Implicit means direct assignment. Implicit means direct assignment. Watch it. I assigned I directly to OBJ. Yes or not? But same way tomorrow, I cannot say int j is equals to OBJ now. Why, sir? Anything can be assigned to object, I said, no? But did I say object can be assigned to anything? Huh? I did not say that. What did I say? Anything can be assigned to object. That only I said you. I did not say object can be assigned to anything now. Are you clear? So, this cannot be done directly. How to do? Understand, man? That is simple English. Read the statement. Convert to into 32. What should be converted? OBJ. And now it is converted into an integer. And this is called as unboxing. Are you clearer or not? Now see, this is implicit. What is it? Implicit conversion. What is that, sir? Implicit conversion means converted without using any conversion mechanisms. Converted without using any conversion mechanism. See, directly assigned. But this is called as explicit conversion. Means converted by calling a built-in method called as 2 into 32 under a class called as convert. This is our another predefined class. What is the name? Convert. Under that, 2 into 32 is a static method. Like this, we have methods called as a 2 double for converting to double, 2 boolean for converting into boolean, 2 date time for converting into date and time. Are you clear or not? So many methods are there. So did you first understand the difference between implicit and explicit, all of you? What is implicit? No conversions used, straight away assigned. Explicit means straight away not assigned, used some conversion. How did we? We are calling this and converting, but here we are not calling anything, directly assigning. That is the difference between implicit and explicit. Boxing can be done directly, but unboxing requires explicit conversion. Unboxing requires explicit conversion. So all of you, say this is what I taught you today. First I started with value types and reference types. Next I explained you nullable value types. Read, man, read, I'm telling you. Practice, read. Okay, next one. Typed variables. Next one is a table telling you difference between var and dynamic. I explained you var and dynamic, and here the program var dynamic, under which I've written you about vars and dynamics here. And then boxing and unboxing. What is boxing? What is unboxing? What is convert? Predefined class. Okay, try